Well, good afternoon to everybody on the West Coast. Thank you for spending your conference time with me. We have an exciting topic ahead of us that I can't wait to share with you. So today's the day that we're going to rethink data visualization. And instead of calling it data visualization, we're going to think about it as data accessibility. Now, in order to do this, first, let's take a look at data visualization and understand why it's been a valuable tool that's been used for hundreds of years. So to do this, we have to think about our abilities as human beings. And most of us have this natural capability to just take in and process information in the environment around us. And we're doing it all the time, whether we realize it or not. We have this natural ability to pull out trends and identify patterns and outliers. So let's put this capability to the test. Let's take a look at this apple, for example. I think we can all agree, just by its very appearance, this is something that might look tasty. You might want to eat it. In comparison, the very appearance of this second apple might churn your stomach a bit. I know when I was putting my slides together for this presentation, I think I puked in my mouth a few times just by looking at this. We can understand pretty quickly that somebody has been here before. And in other scenarios, we can tell that many people have traveled these steps before. When looking at this image, imagine that you're on this beach and you're trying to find a place to camp for the night. I highly doubt that you'd want to pitch your tent within this windswept forest that clearly has been battered and exposed to the elements. Now, when we think about the 5 examples I just shared, I think it's safe to say that we all drew these conclusions very quickly without really studying the images. So, of course, this ability we have as human beings has been studied. It's called preattentive processing. And it's our ability to subconsciously accumulate and process information presented by the environment around us. And really, this natural ability that most of us have is something that has been integral to our survival as a species for hundreds of thousands of years. Now, visualizations are tools that leverage these natural capabilities that we have. And if you think about a visualization, they're typically used to help us make sense of a large and complex data set. They amplify our cognition of a difficult problem space. And if a visualization is done very well, it can improve our decision making. We can make better, more well-informed decisions. So let's see if we can spot some trends and patterns very quickly in this visualization. This is actually one of my all-time favorite visualizations. Some will tell you that this is one of the greatest charts of all time. In my opinion, this is actually one of the greatest anti-war posters of all time, and it's depicting Napoleon's invasion of Moscow during the Patriotic War of 1812. So a couple of patterns that come forward here, and this will become apparent once I start explaining the graph. The gold bar here, or line, that is plotted through this map represents the army's starting point and their endpoint in Moscow. And the thickness of that line at any given point represents the number of people that were in Napoleon's army, the number of troops that he had. The black line actually represents their return retreat. And again, the thickness of that line represents the number of troops in the army at any given point. So once we know that, a very glaring pattern comes forward here. We can see that Napoleon started out with a lot of troops, somewhere on the order of 400,000, and ended with a very small fraction of his army. So this was a crushing campaign. So a couple things that happened. We can see that at no given point in time was there this major clash where the army was decimated. This all happened over time. And when we start to analyze history and understand what happened, this visualization supports a very rich story. So for example, the map does a nice job of showing Napoleon's ego here. His troops were undersupplied, and they didn't take into account some of the environmental factors and weather conditions that they would encounter on their journey. So, for example, as they're approaching Moscow, the Russian army used guerrilla warfare tactics and slowly whittled the army down to the point where it was about 1/4 the size of what it was when they left. And then on the way back, the army was exposed to the harsh weather conditions in the fall and winter of that year. And if we look at this bottom graph here, this is actually a plot of temperatures over time. And you can see these temperature values are very low. And we can correlate that visually with the thickness of the bar representing the Army's return journey. And we can pull out from that that a lot of troops died of hypothermia, the continued guerrilla warfare, and this was just a crushing blow to the Army. One other interesting trend or pattern that you might have been able to spot if you look very closely at this graph is this river crossing. So this is the Bresnia River, and you'll notice that the Army was cut in half here, and that's because the French Army was actually put in a position where they had to burn and destroy the makeshift bridges they were using to cross the river, thus stranding about half of the remaining army. So I think this visualization does a nice job of surfacing those patterns pretty quickly. It's very apparent that something terrible happened to this army, and as you start to dive into more of the details, we can extract more visual patterns from this visualization that really tells the story of this particular campaign. Now at Google, we use visualizations in many of our products. In this recent era of COVID, we've used visualizations to help people understand the spread of the virus. This is showing the geographical distribution of cases. We've helped billions of people understand case rates over time. So you may have heard the term flattening the curve in the US. This refers to a visualization like the one we're seeing on the left here, where we're hoping to minimize spikes in cases, and visualizations like this can help track just that. Recently, we've been seeing that vaccines are being rolled out across the world. We have charts that allow billions of users to understand how vaccines have been administered in their local areas and understand what the rate of vaccination looks like. I work on a team in Google Cloud. We've created visualizations that help our customers, like developers, understand how queries are executing on their databases. We've created visualization tools that help designers and content strategists design better taxonomies and better plan what kind of content is going to appear within different nodes of an information architecture. And then Alphabet is known for working on moonshot projects. In the past, we created visualizations that helped loon operators understand the external factors affecting a balloon's ability to connect and communicate with a ground station. So these are some interesting examples of visualizations and how we're leveraging some of those natural capabilities we have as human beings to understand very complex areas. Now we're going to create a visualization together here, and we're going to keep it simple, nothing fancy. I want you to think about these two numbers, 7 and 14, and I want you to think about ways in which we can effectively visualize them. Go for quantity of ideas here. There's really no wrong answer. I actually added my own sketch here just to hopefully get the creative juices flowing. As I'm talking about this, I just want you to think about different ways in which you can possibly do this. A few of my ideas included just simply writing out the numbers like we see here in the upper left. I also expressed them as Roman numerals. I used a series of tick marks and slashes. The top row, if you count them, that equals 7, the bottom equaling 14. I used Gestalt principles to group a series of dots. So we have a cluster or group of 7 dots here and a cluster of 14 dots representing the two values. I did the same with interlocking triangles. Now, if you think about the relationship between the two numbers, 7 is actually half the value of 14. So this bar is half the length of the bottom bar that appears beneath it, thus representing that relationship. And I took that a step farther, and I created a donut chart where half the chart is filled in, the filled part representing 7, and the chart as a whole representing 14. And then I represented that relationship with the area of the circle here. So the first being half the area of the second, thus representing the relationship between those two values, 7 and 14. Now, all of this that we covered so far is well and good. I hope you can see why visualizations have been an important tool and a useful tool over the course of time. But I don't think we're thinking about this from a big picture perspective. This is all really good, but we're making a bold assumption here. We're assuming that everyone can see, right? So I want you to go back to the thought activity now and think about how might we represent these two values of 7 and 14 to someone who is blind. I want you to take a minute to think about that. I have a few ideas of my own, and I'm going to play them for you now.
7, 14.
So I think it's apparent that we need to rethink the approach here a bit. So I work on a visualization team. My team wrote the specs and guidelines for material design on data visualization. And back when we had partnered with the material design team, they asked us to think about, what does data viz and charting mean for Google? Now, we felt that this was a pretty difficult question to answer. And to do this, we partnered with several practitioners in several different product areas across the company. And what we did was we came up with these guiding principles for designing any chart. And really, we were focusing on Google Charts. But if you look at these principles, you can apply them to your own charting work. And it'll really kind of augment your design work and the way in which you think about charting. But this presentation isn't about data visualization. It's about data accessibility. So let's see now how these guiding principles can be applied when making accessible data experiences. Now, to start, we reordered some of these principles because there are a few dependencies here. So the earlier principles are a bit more foundational in nature. And then if we can start thinking about how to apply them, once we do, then we can move out to some of the more delightful principles that appear later in this list. And then finally, we'll talk a little bit about how to scale up some of these ideas at the end. So arguably, the most fundamental and foundational principle is providing the right structure. There's a couple of ways we can think about this through the lens of accessibility. So the first is all about navigation. We want to structure our charts in a way so that they're easy to navigate, especially for a keyboard user. And let's take a look at this example. This is a visualization of COVID hotspots by county in the United States. And you can actually interact with each of these counties to find out a little bit more about COVID-specific metrics in that county and local area. Now, at first glance, you might think, okay, you could use the tab key to navigate through all the counties in the United States. But there's actually 3,006 counties in the US. And I want you to ask yourself this: is it responsible of us to require our users to tab 3,006 times just to get through the chart, especially if they're only trying to interact with an item that appears after the chart, such as a metric or point on this data table? And I think the answer to that is no. So if we go back to the map, there are several ways we might think about structuring it. Perhaps we can tab through each of the 50 states, select a state, and then navigate through its counties with the keyboard. Okay, well, 50 tabs is better than 3,006. That could be one way of looking at it. I would also encourage you to think about other keys we could use to navigate the counties. Perhaps we can select the country as a whole and then use arrow keys to find out about COVID cases in each county and the hotspots. Perhaps we set a threshold, and if there are cases that exceed a specific threshold, we could use keyboard shortcuts to highlight those counties, because really that's what the graph is showing here. This is a bit more of an abstract visualization. This was provided by LinkedIn a few years back, where you could use this tool to visualize your LinkedIn network and see how all of your connections are interconnected. They actually categorized your connections based on how tight-knit the different circles were. So for example, if you worked with a lot of people at the same company and they were interconnected, they could be represented by a category here. The categories are color-coded. So if you think about this, it's a little bit more abstract than the map we saw previously. And think about ways in which you might use keyboard navigation to navigate this visualization. Perhaps there's a way to navigate through the different categories or groups that you're connected to. And then maybe there's a way to select a group, learn a bit more about it, and then navigate through the people that exist within that group or that are part of that group. Maybe there are other interesting ways to navigate individuals. Maybe there are keyboard shortcuts that you can use to navigate based on some level of connectedness or interconnectedness within the network. There's a lot of possibilities here. But the point I'm trying to make is a lot of visualizations are complex in nature. They could have anywhere on the order of hundreds to even thousands of data points. So really take some time to think about how you're going to set up an intuitive structure for keyboard navigation that really lets somebody explore the data in more detail. One of my favorite data viz best practices is this idea of providing an overview with a path to additional detail on demand. So don't add all the information at the topmost level of the visualization. Think about how you can use the visualization as a tool for highlighting interesting areas and allowing your users to drill down and investigate information on demand. And I think this illustration here does a nice job of showing that. And also, when we're thinking about navigation, think about how to set up your keyboard shortcuts, your keyboard navigation in a way that complements this process of drilling down for more information. Something else we might want to think of in addition to navigation is when we're building our charts, ensuring that we're using the proper HTML elements and attributes that best describe the chart to your browser. If you're not familiar with ARIA, it stands for Accessible Rich Internet Applications. Essentially, this is a set of properties and attributes that can describe all aspects of your chart, from the chart as a whole, all the way down to the X and Y axis, the labels, and the individual data points. And the reason why we want to set this up properly is so that the chart can be interpreted to your browser's accessibility API. So then screen reader users understand the purpose of the chart, the information it's trying to communicate, and maybe they can even pull out some insights from that chart. Over in the left here, I just wanted to highlight that in the last 3 years or so, the W3C has added some charting and data viz specific roles, landmarks, and attributes that you can use. If you're a developer and listening to this talk, I would encourage you to go out to the W3C and take a look at the exhaustive list of properties and attributes that you can add in your code when you're building your chart. This slide always makes me laugh a bit, but tables are actually still a viable option. We've been finding that screen reader users or folks using assistive technology are actually fairly proficient in extracting insights from a spreadsheet or a table. So in some scenarios, it might be nice to provide a method for accessing the data in this structure and format. I'm not suggesting to use this as a catch-all. If you have an accessibility testing program in place, I would suggest evaluating, through that program when it's appropriate to resort to a solution like this. Before I get into my next guiding principle, I want to tell a story about this chart. So this is a map of London that was created in 1854. This was created by Dr. John Snow, and at the time, cholera was a widespread disease, and there was a lot of fear and panic about it. The citizens of London weren't sure how it was spreading. There were people who thought it was airborne. There was a lot of misinformation out there. And what John Snow did was he started to place tick marks at the address of all the known cases. So as more cases came up, he marked them off on the map. And over time, he started to notice a pattern emerging, that most of the cases existed in proximity to the local pumping stations. So this visualization actually led him down the path of investigating the disease, understanding that it was actually spreading through the water. And then ultimately, he used this as a tool that he took to London city officials and used it to convince them to shut off the pumps, thus curbing the spread of the disease. So keep this story in mind. I'm going to talk about this next principle, lending a helping hand. And this is all about providing the right context. And if you think about people who can't see, we can think about it as providing the right takeaways up front, maybe summarizing the chart in an elegant way, pointing out what is interesting, that those of us who can see could spot the pattern, but for those who can't see, what is it about the chart that's interesting? And a lot of charts have different purposes. So if we go back to the Jon Snow chart, this chart was a bit exploratory in nature. It wasn't really meant to answer a specific question, but it was meant to help Jon Snow investigate the spread of the disease. This kind of gave him an idea of the right follow-up questions to start asking to further his investigation. This chart is a bit more exploratory in nature, and there are a lot of charts out there that are like this. Typically, an analyst is using a chart, and these people are interested in the shape of the data. Just like Jon Snow is interested in seeing the spikes in cases in proximity to the pumping stations, analysts are interested in spikes in data, unexpected dips, and what does that overall shape look like? Now, in comparison, other charts are a bit utility in focus. They answer a predefined set of questions, like the stock chart. So we can safely assume when someone's looking at a stock chart, they're interested in the current value of the stock. Is it higher or lower than yesterday? And what is the recent trend looking like? And then in this example, this chart actually shows the efficacy of the measles vaccine after it was introduced. So the main takeaway here is very proactively highlighted front and center. We can see this thick black line that represents the point in time in which the vaccine was introduced. And then using these compelling visuals, in this case, the heat map, we can see that there was a rapid decline in cases shortly thereafter. And typically, charts and visualizations like this are going to support a larger narrative. They typically live in news articles. They could be used in presentation dashboards for executives, or even like executive summaries and reports. And they're typically used as an aid for proving a point that has already been mentioned in a way that displays like the data backing it, stuff like that. So I showed 3 different examples here that were each drastically different from each other. They had different purposes. Dr. Jon Snow's chart was more exploratory in nature. It was helping aid an investigation. The stock chart was meant to answer a very direct set of questions that we're all aware of. And the vaccination chart, the heat map, was used to support a larger narrative. So when you're setting up your charts and thinking about their purpose, not only think about the questions that people are answering, but think about the chart's role in the greater narrative. And that'll start to help you think about ways in which you can highlight what is going to be interesting to the people who are viewing the chart and consuming the data. Another thing that we might want to think about is giving clarity of focus. This is a really good guiding principle for charts. There's many ways in which we can interpret this when we're thinking about accessibility. I'm actually going to focus on one of the more controversial pieces of a chart, or elements, if you will, and that is color palettes. So it's important that if we're creating accessible data experiences to follow the WCAG 2.1 standards, they require us to use colors that have a 3:1 contrast ratio with their background, whether they sit on a dark background or a light background. But as we're looking at this palette, you can see that it's very bold, it's very saturated, and it could potentially command too much attention. It could draw focus away from other areas of your screen or layout that might have more important information. So in this example, we're looking at a chart that's pretty technical in nature. I'm not going to ask anybody to try to understand this. This is a visualization of log events that are occurring over time. But someone who's looking at this chart is more interested in anomalies and errors than everything that's happening. And the stacked bars in this chart try to describe that. But if we start thinking about other ways to use color and apply it, it's always important to use something other than color to convey meaning. So that kind of opens up a new world of thinking here, and ways in which we can direct someone's attention in this chart. We can use graphical accents, iconography, textures to convey meaning. And if we start to apply that in a way that's WCAG standard compliant, now you'll notice in this chart, our attention now shifts to the bottom segments of each bar in the histogram. And now we have this better picture of the alerts and anomalies that are occurring over time. Well, we can still get a sense for the total amount of logs that are occurring over time. So here's some examples that we've been playing with, ways in which we can add outlines, other graphical attributes to colors to convey meaning. And you can get pretty creative here and still remain in compliance with WCAG. And I would encourage you to do this when you're designing your chart, because you can now open up some more opportunities for not only creating a beautiful chart, but drawing focus to what matters for the people who are viewing your chart. I just wanted to show this slide because this was a pretty clever use of animation to help someone understand the sequence of events here. It also draws your attention to a step that's happening later in this process that is presumably important. So there's many different ways that we can approach this, and I think this unlocks some new opportunities to be creative in chart design and how you can direct focus within a chart while still providing colorblind friendly palettes and remaining in compliance with WCAG and still assisting low vision users who are viewing your charts. The next principle, this is just being responsible in general, accessibility aside, it's all about being honest, providing transparency, helping people understand where the data came from, citing sources, citing the recency of the data, and then showing how the data was collected. And it's really nice when you can give your viewers access to the actual data set so they can play around with it for themselves and also have the ability to draw their own conclusions. It just shows an extra level of transparency. If we look at this visualization of COVID tests administered over time, we can see very quickly that the source is cited here. We can see when the chart was last updated, and at the bottom, we see some notes about data collection and how it was used to render the visualization. Delight is always a fun guiding principle. We do want to be thinking about this. I'm not going to be too prescriptive here with my thoughts, but I want you to think about this. We get a lot of questions from people about, are we spending too much time thinking about accessibility? Are we compromising the experience for everybody else? Are we degrading the aesthetics? Are we ruining the visual design? And for this, I really think if you really think about it, you can create an experience that benefits everyone of all abilities. I also wanted to think about it this way too. Right now, according to the CDC, 1 in 4 people in America has a disability. There's also many more people using screen readers and assistive technology than you might realize. According to Stack Exchange, there's over 4 million screen reader users in the United States. And if we're not thinking about these people and how to design for assistive technology, we're really abandoning them. So think about how much impact you have when you can bring millions of people on board and they now have a way of viewing their information where they didn't before. So I think this is a good case for why accessibility matters. And as I previously mentioned, we really don't need to compromise the design. If we look at this Nest Hub, assuming that we just asked it about a particular stock quote, let's think about how we can create a delightful experience here. So the Nest Hub ships with some really nice core capabilities. It can provide a narrated response to your query. It provides audio feedback, and it has this screen where we can display a nice visualization. So if you think about the guiding principles we previously covered, we could draw a very nice visualization here using elegant shapes that even somebody with low vision can see and interpret. If you think about the audio response, we can provide a nice takeaway, especially for a stock chart, because we know what questions it's meant to answer. And if you think about this idea of audio, we could add an element of sonification to the chart. So imagine you can listen to a few musical notes or bars that play that help somebody who's blind understand the recent trend line. And that holistic experience can really be empowering and insightful for anybody who's using the device and asking this question about the stock. So I covered some principles that can be directly applied to your data experiences. Now let's talk about scale. And the way I like to think about scale here is if you have the ability to contribute to your company's design system, if you're building a design system or a library of reusable components, think about how you might add charts to that library. And if you're thinking about data accessibility, all that know-how and knowledge should come for free in the chart, because accessibility is a first-class citizen. Then anybody who's going to integrate that charting component or your design can be rest assured that they're getting all your accessibility knowledge for free. And that's going to be passed on to your end customers. So a lot of people are benefiting from this. And this is a way in which you can scale up your accessibility knowledge across your organization. So I'll leave you with a parting thought here today. We covered some guiding principles for creating accessible data experiences, but we still somewhat focused on charts and visualizations. And if we continue down that path, that's all well and good, but I think we're missing out on a larger opportunity here. And that is to answer this larger question: how might we make data accessible to everyone? And the answer to that might not be a chart. It could be some sort of alternative, like a multisensory experience, for example. So if you can take anything away from this talk, it's this: I'm asking you to join me as you continue working on your day-to-day work in answering this question, as we all work together to create products that are more inclusive and accessible for everyone to enjoy. So thank you. If you liked my talk, feel free to follow me on Twitter and LinkedIn. I post a lot of information about visual languages, data visualization, accessibility, and drawing. So I look forward to connecting with you there. And if you have additional questions after the conference, feel free to reach out and we can chat. Thanks again.